In the depths of the Fitzpatrick Hall of Engineering basement,
in the Robotic Football Design and Development Lab,
a group of 4 college students use exactly 71% of memory to create
Game Girl Basic, trademark.
by WondEEr WomEEn and ShaEE.
from the minds of our genius innovators. We built our own handheld arcade game using an LCD screen and an Arduino Uno. We chose to code the classic arcade game Frogger using a leprechaun as the user-controlled sprite and obstacle shaped as #33truckin' Josh Adams.
In order to play the game, the user interfaces with the buttons in order to control where the leprechaun goes. The goal of the game is to get to the other end zone without being tackled by the football players.
In order to design the pixelated characters and backgrounds, we used Piskel.com. Piskel allowed us to create the sprites pixel by pixel and then hardcode the design in the Arduino IDE using the Adafruit graphics library.
Here you see the Arduino Uno, which we used to compile all of our code on. This code was then displayed on the LCD that is now shown. In order to interact with this LCD, we used the basic controller developed here. Due to bouncing that occurred from this controller, we developed a parallel circuit so that the bouncing would be eliminated.
Here we have the code for the IrishFrogger program. First, we include all of the necessary libraries, which is just the Adafruit graphics libraries and the Arduino SPI, before we include all of the definitions for the buttons and pins on the Arduino and the colors that we're using for the LCD screen. And then we have some definitions for the constant variables that we're using throughout our program. Next, we have the sprite struct, which is the most important part of the program. It has the X and Y position and row and column, and the group number, which is used for the player's obstacle size. And then we declare all of the sprites, and we go into setup, where we define all of the pins, seed the random number, and initialize all of the players and leprechauns. Then we start the LCD screen, we draw the background, all of the leprechauns, and all of the players. Oh, there's only one leprechaun, but all of the players. And then we go into our loop. Constantly, it's calling the move player function, which advances the players one column over, and it's checking the up, down, right, and left buttons for being pressed. And if it's pressed, it will move the leprechaun accordingly. If you get the leprechaun into the end zone, it will call the draw win function. And if not, and you get tackled before that, this is constantly checking for tackles between any of the 14 players and the leprechaun. Next, we have all of the function definitions, like draw background, replace background, which gives the illusion of the leprechaun moving when in fact we're just replacing where it was with a colored in square, and we're redrawing the leprechaun just one column or row over. The game over and the win screens, and here we have an example of how we created the sprites and drew them on the LCD screen. We couldn't draw them pixel by pixel using a for loop, and we're still not sure why, but you can reconstruct them using all of the Adafruit graphics libraries features like fill rect, fill triangle, etc. And that's most of our code, to be honest. Here's more of the same. This is the move player function, and we call that all the time, as you saw. And that's basically it for our program.